Good evening, friends. Welcome back to Brain Sizzlers. Today we are going to deal with the topic identifying whether a given possible number is prime or not. So, there are basically four understanding principles from which we can conclude whether a given number is prime or not. We will watch it one by one. The primary and basic understanding is that apart from 2, any other even number is obviously a composite number, so there is no need to check for any even numbers for whether it is prime or not. The next understanding, the understanding number 2 is that, so it is quite sure that we are going to check whether the number is prime or not only for odd numbers. So if we take any odd composite number, it will definitely not have a factor which is an even number. So we need to check out its divisibility with a list of odd numbers. So the list of odd numbers goes like this: 1, 3, 5, 7, 9, 11, etc. So in essence, we need to check the particular number's divisibility with the list of all odd numbers. So in our subsequent understanding, we will narrow down our list of numbers with which we check the particular number divides the given number, which needs to be checked whether it is a prime or not. So the extending our understanding, among the odd numbers also, it is enough if we check only those odd numbers which are prime. There is no need to check for odd numbers which are composite. Okay, the reason being that we will first make a list out of all the odd numbers in ascending order. So 1, 3, 5, 7, 9. Here I have encircled the odd composite numbers, namely 9, 15, 21, 25, etc. So when we look at this, when a particular number is not divisible by 3, for example, 3 being one of the factor of 9, it is definitely not going to be divisible by 9. And similarly, when a number is not divisible by either 3 or 5, it is definitely not going to be divisible by 15. So, if a number is not divisible by yet another number, the form will not be divisible by the latest multiples. That is, if we look at it as a fragment approach, if 87 is not divisible by 11, 87 is not divisible by 11, which is quite obvious. So the point is that any of the multiples of 11 will also be not divisible by 87. Simply because if we split up 87 as a fragments of 33, there will be 2 fragments of 33, and every 33 can be written as 3 pockets of 11. Okay, so 87 is written as 33 plus 33 plus 21. So it is quite obvious that 87 is neither divisible by 11 nor divisible by 33. Suppose if we were to look at a number which is a multiple of 33, it can simply be written as n times 33. But each 33 can be written as 3 pockets of 11. So in turn, n times 11 into 3 is nothing but n times 33. So if a number is divisible by 33, it is compulsorily divisible by 11 also. So there cannot be a number which is divisible by 33 but not divisible by 11. That cannot happen. So our understanding is being strengthened by this simple example. So further narrowing down our list of numbers from the understanding 4, see, if we look into the factors of a given particular number, say for example 40, we can list out, write this 40 as a product pair of its factors. Say 40 can be written as 1 into 40, 2 into 20, 4 into 10, 5 into 8, etc. If we just look into its product pairs, on the left hand side we have a set of numbers which are obviously less than the square root of 40, and the right hand side has numbers which are greater than the square root of 40. So this holds good for 56 as well. So in general, if we want to check out whether a given number is prime or not, we need to check only its divisibility with odd prime numbers which are less than its square root. Simply because if any of the, suppose in 40, if any of these 1, 2, 4 and 5 are not divisible with 40, it obviously cannot be divisible by any numbers higher than that, which is nothing but the square root of 6. So for 127, I need to check the odd prime numbers which are less than 11. That would be enough because square root of 11 lies between 11 and 2. To conclude, we can say that to check whether a number is prime or not, we need to check all the set of all prime numbers which are odd and which are less than the given number's square root. We can make an additional note that for divisibility of 3 and 5, there is no issues because we can, at hindsight, we can say whether a particular number is divisible by 3 by simply adding on the digits of the number so that the summation is divisible by 3 or not. With respect to 5, the last digit of the particular number should be either 0 or 5. So, our exhaustive checklist for a given number, whether it is to be divisible by any other number or whether the particular given number is a prime or not, our exhaustive checklist is as follows: 7, 11, 13 and up to the square root of the required number. Thanks a lot for watching patiently. Have a nice day.